Okay, so what are we going to do here to calculate the actual change in internal energy? We have to do it in terms of P naught and V naught. So let's go back to this first law. We know that no work was done, so the only change in energy would be here to here. My question is, when I look at this question, it says for the series of the problems, the net change in internal energy for the series of processes. So am I doing this step by step, or am I doing it for the whole bailiwick? The whole mess? What is the question asking? Is the question asking me to do A, B, B, C, C, D, list all of them, or is it do A, B, C, D, A, and tell me the net change in internal energy?
All of them because of that. That includes everything.
Yeah, when it says for this series of processes, they don't want me to actually do step by step. They want me to do the whole thing. Okay? The whole shooting match, yep. So the net change in internal energy. Well, let's see. In this set of processes, so how would we do that? Well, when you go around a whole loop, what happens in this reversible process?
Well, it eventually gets back to where it started.
We get back to where we started. So what would the net change in internal energy be?
Zero.
Yeah.
Because it got back to where it started.
Yep. That's all you had to write. Because you did the whole process. They told you it was reversible. So the change in internal energy, you get back to where you started. Therefore, there's no internal energy change. Okay? Each step will change the internal energy some. But when you get back to where you started, you're back where you started. There's no difference in, it's kind of like you guys remember in physics 1 where we talked about displacement. You could run all over the world, and if you come back to where you started, you've gone nowhere in terms of displacement. You've got distance, but no displacement. So if you get back to where you started, you have no change in internal energy. Okay? Now, net heat absorbed. Well, let's see. That one we should be able to do pretty quickly because this was, the net work done was 2 P naught V naught, right? Delta U is 0. So then change in U equals Q plus W. So 0 equals Q. Was the gas done on, was the work done on the gas or by the gas? Because we need to check a sign here. So this is, right? The work was done by the gas. Energy left the system. So this is energy leaves the system is my negative sign. So when I do this, so what's our heat energy that had to be absorbed? We had to put in the same amount of heat as we lost during the work to end up where we started. Does that make sense? So this is just straight first law, but we have to remember that this is a cycle, so don't overthink that one. And then this one, you use your first law with delta U being 0. You found the work in part A, so now you've got part C. So that part in a normal, I'm using it as an example, it's the first time you've seen it. But once you've done a few of these, that part would go really quick. The first part took a while. The second part should go pretty quickly. Now, last but not least, determine the heat transferred during process 2. Okay. Process 2 is just it is heated at constant pressure until it reaches a volume of 3 V naught. And they want us to tell us how much heat is transferred. Well, let's see. delta U equals Q plus or minus W. And that process was one where we went straight across, right? So the work was 4 P naught V naught. It was that top bar. So, and it was work leaving, so this would be do we know what our delta U is? Because they're asking me to find the heat transferred. We know that our temperature had to go up, right? Because this one was 6T0, 6 times bigger than the original, 3 times bigger than the last one. So what would have to go here? Well, let's back the train up a little bit. Q1 V1 over T1, right? So in this process, P2 is canceled, it was isobaric. So what do we have? V1 T2 equals V2 T1. Is there some way that I could solve this? Because I know what that's got to be, so that I could have a statement about pressure and volume and then be able to combine these two so that I get an answer here. Let me scroll the screen back down so you can see. Let me see if I can maybe restate that. We know that when we did this process right here to here. So this was T0. This was T1, which was 2T0, 6T0, 3T0, back to here. Is that right? I think that's right. So is there some way that, since these are all the P's and V's are in the same equation, is there some way that I can write this 6T0 in terms of P0 and V0 so that I'd have like terms? That's what I'm asking. Or is there a different way to attack this? Should we be using one of our other formulas? Because you know, like PV equals nRT. And they told us we had an ideal gas, but they don't tell us how much ideal gas, right? So this would be my next thought. But here's the thing. If the temperature went up by 6 on this side, what has to happen on that side? So would it not be fair to say that this is 6? Or can I do that? Can I use the ideal gas law like that? Let me shut off while we're thinking. Can I just, how can the ideal gas law get used, or can it get used like I just did? I mean, theoretically, do we have the same amount of gas at the beginning and the end? So then this number, the N, should be the same both times, right? And whether it's a number of molecules or a number of particles, the R should also be the same. So if one side got multiplied by 6, the other side would also have to be multiplied by 6. Does that make sense to you? Okay, so then can we just do what we said, or am I somehow misusing the law? And if so, if I'm misusing the law, how can I not do that? Good, because you should. This is exactly what you should do. Is go, hey, N and R are what? They're just constants. They're just numbers, right? So if I know over here I had 6 times T0, somehow I got 6 times T. So what would happen? So I don't have to go through all this. I can just say, and I'm going to move to the middle of the board so they can see a little bit better. Make this argument a little closer on the left side of the building, as it were. So we know that at A, we have P0, V0, T0, and we know it, or excuse me, B, at A. Which one are we doing? Oh, we're doing the network, right. So we know that we end up with 6 T0, which means by the ideal gas law, regardless of which form you use, these two numbers stay the same the whole way through. I didn't add more gas to the problem. I didn't remove gas from the problem. I just got some amount of gas. This number is a constant on the formula sheet, so those don't change. So if I made this one times 6, this side is also times 6. So now to do our process, we know this would have to be 6 P naught V naught. Q, I don't know. Work was 4 P naught V naught. So Q must be 10 P naught V naught. Okay? So that's all you have to do. Remember that the combined gas law, even if you can't get them all by themselves, you can go back to the combined gas law and said, whatever I do with PV has to be the same thing I do to T, because you have constants in the middle. Okay, so I'm going to stop right there and let you think. I don't think we need to do another problem. I think we just need to breathe a little bit. And I will take, if you guys have some questions, or you guys out there have some questions on 10C or 10D, I'll be happy to take those. Otherwise, we're almost to time. We've only got 7 minutes before we go into DLRTI. Distance learning, something. Oh, what's the RTI? RTI is intervention. Remedial, no, it's like, I don't know. What does RTI stand for? I don't know, but it's basically, it's an intervention for you if you need help or if you need to be challenged. So if you need to be, it doesn't have remedial in the name of it. Response to intervention. There we go. Thanks.
We're intervening for them doing their work.
Right. So for the distance learners, the problem from the first quarter, and you guys probably already know this, is that we didn't all do our work like we should have. And I know in a class like mine, particularly if you miss a few days, then it snowballs you. It's real easy to, oh crap, now I got to do this and this, and I didn't know how to do the first thing, and now we're, you know, even when you're in here, that happens. Like if you're live in person with me, you may still have that happen. It's just tough. And so some of us stumbled and fell a little bit, but yeah, it's gonna be all right.
Sometimes I just want to lay down and take a nap.
Yeah. There have been times in my life where I have propped my feet up on my desk and sat my rolling chair up there and taken a nap. But usually I don't do it in the high chair, I do it in the lower chair. Because in the high chair, if you fall out when you're asleep, it's a long way down. So for you guys, if you want to stay and work and ask questions, that's great. Oh, and look, Chris told us it's response to intervention. And if you don't need to, then you're welcome to go and do study hall things or go play Fortnite. Ghost of Tsushima. Whatever it is. Whatever floats your boat.
Video game.
How did they do? Sarah Ruth?
Decent.
Decent? Well, they've only done this for a couple of days, so,
The packet that had the bar drive,
uh-huh,
they didn't do as well.
okay, all right. That's okay.
But it wasn't like overall terrible.
Yeah. Well, when it's the first time they've done it, I just want